So here's some more examples now. Usually when I email the notes, like if I have a let them try, like if I have an example like this where it says let them try, I remove the solutions. But for the next slide, I forgot to do that. So let's do it together then. So we have 45 degrees, right? To get this, okay, as, to get this in terms of radians, again, you do 45 degrees. Let me just fix something. Just notice this, it should be a 6. Okay. So here we have 45 degrees, right? You multiply by pi over 180 degrees. Same idea, right? The 108, the degrees are going to cancel. 45 times pi over 180. 180, though, is 4 times 45. So the 45s cancel, right? Let me just draw that. So you can see these cancel. We get pi over 4. For the next one, 135 degrees, same idea, right? We multiply by pi over 180 degrees. Okay. Right? The degree symbols cancel. Again, this is a way to remember it when you don't have the notes in front of you. You want the degree symbol to vanish. Okay, well, how can that happen? It can happen if you have degrees in the denominator. Okay. So we have this product, which is equal to 135 times pi over 180. Here I showed more work. As you can see, 135 is 45 times 3, and 180, as before, is 45 times 4. So those cancel. You can see these cancel. And you have 3 pi over 4. Again, the answer has pi in it. That's fine. You don't write pi as a decimal. Next one, pi over 3. Okay, we have pi times 180 degrees over 30. So we end up with this. The pi's, those cancel. We have 180 degrees over 3, which is 60 degrees. This one I caught the mistake. We have 5 pi over 6. So again, we want that in radians, okay? That's 5 pi over 6 times 180 degrees over pi, right? So we get this. I think that what I did was I copied this from here to here when making up my notes. I forgot to get rid of the 3 here. So I made it into 6. You can see that the pi's cancel. This doesn't. So the pi's are going to cancel, as you can see. And so we get 5 times 180 degrees over 6. And, you know, if you do that, you end up getting 150 degrees. Finally, 2 pi over 5, same story, right? We want to convert it into degrees. So we multiply by 180 degrees over pi. The pi's go away, as you can see. So we're left with 2 times 180 degrees divided by 5. And if you do that, you end up getting 72 degrees. This I did in my calculator, so. This is what we get. Any questions on this?
So on like a quiz or something, if we just left it as like 45 pi over 180 or something, would you take off points?
No, no.
Okay.
I mean, you should really write it in lowest terms if you can, but no, I didn't really go over that, so I'm not going to be that crazy. I'm not going to be that strict, excuse me. So So if you left it as 45 pi over 180, that's fine. Awesome question. Any other questions? Okay. That's all 5-1 I want to do. There is the other stuff in there, but for time consideration, I'm going to skip over it. If you do want to see the definition of what a radian actually is, it is in the book. It has to do with arc length. That's a different story, though. Now, I want to go on to Chapter 5, Section 2, which is trigonometry. As you can see, we're mostly going to focus on trigonometry of angles that are in a right triangle. That's where, like SOHCAHTOA comes into play. Again, you could generalize that to any angle, but we're not going to do that for time consideration. And then we'll actually calculate trig functions of certain explicit angles. In other words, I'll show you, not today, but we'll see actually what sine of 30 degrees is, what cosine of 45 degrees is, that kind of stuff. I mean, what's nice is those values are programmed into your calculators, which is nice. That reminds me also, when you're doing these problems, make sure the units in your calculator are correct. If I give a problem and I want your answer, and if in the problem the angle's in radians, if your calculator's in degrees, your answer, odds are, it's not going to be right. So you make sure you want to be careful, is what I'm saying. All right. So basically, we want to get the trigonometry. So I'm setting it up here. We're dealing with, as you can see here, a right triangle. Basically, with a right triangle, right, as you can see, this little, supposed to be a square, looks kind of like a rectangle, in that, that's basically notation for, let me just fix them. That's notation for the 90-degree angle. That notation is for. All right. See, we use a tiny square. So what I'm doing is I'm letting theta, that's what this Greek letter is, okay? Theta. I'm using theta to denote another angle. So theta is actually between, I mean, that's true what I wrote up there, but it's better to write it this way. It should be 90 degrees. If you add up the angles in a triangle, okay? If you add up all the angles in a triangle, you have to get 180 degrees. But that forces, since we have a right angle here, that forces theta to be less than 90 degrees. So this is our angle theta. You could use the angle up here if you wanted to. Good. Let's stick with this one. The sides here, they're given labels. OPP here. This is the side opposite the angle. OPP is for opposite. That's the side opposite the angle. ADJ, that denotes the side next to, adjacent to, that is, theta, the angle. So ADJ is the side next to theta, adjacent to it. And whether you use this angle here or this angle, this hype is hypotenuse. That's always opposite the 90-degree angle. Always opposite it. I mean, if you use this angle instead of theta here, then the sides here, I think, would actually interchange. They're labeled relative to theta. Hypotenuse is always opposite the 90-degree angle. In fact, it's always the longest of the three sides, hypotenuse. Okay. Now, so we have these, I guess this is notation, you could say. From here, you get this. You can define trig functions. What's nice about it is if you have an angle and a side length, and you know it's a right triangle, you can get the length of the remaining two sides. That's what's nice about trigonometry. You know, the Greeks, I think they used this when they invented this. I think they used it for buildings, I think, like architecture. I think it was them that invented it. But again, if you have an angle and a 90-degree angle, and you know the length of one side, you can get the length of all the other sides. And notice how these are defined. They're defined as fractions of one side over another. So sine of the angle theta is the opposite side, length of it, divided by the length of the hypotenuse. Opposite side divided by hypotenuse. Theta here, cosine of theta, that's what I meant to say. That is defined as the length of the adjacent side divided by hypotenuse. So it's the length of this side over the hypotenuse. And then tangent of theta, that's just opposite over adjacent. Opposite over adjacent. You know, the length of the opposite side over the length of the adjacent side. I know SOHCAHTOA here is used as a device to remember these definitions. You know, like S is sine, O here is opposite, H is hypotenuse, adjacent, C is cosine, T is tangent. So that's just a way to remember those trig definitions. Those are trig functions. Notice also that if you have a 90-degree angle and another angle, you actually know all the angles because the sum of the angles of a triangle, you know, that's 180 degrees. So really, if you know the angles and the length of one side, you can easily get the length of the other side using the trig stuff. What's nice is the values are programmed into our calculators. You know, if you went to your calculator and put in sine of 30 degrees, you would know what the answer is. Cosine also. I think cosine of 30 degrees is a half, if I remember correctly. So, all right. So, here we go. And now the three other trig functions actually, there's secant, cosecant, and cotangent. That's what these three trig functions are. And they're defined this way. Okay. All right. So secant of theta is the hypotenuse divided by the adjacent. Cosecant is hypotenuse over the opposite. Cotangent is adjacent divided by opposite. So these are just three other trig functions. And yes, there is a way to remember these. I mean, you're going to have the notes in front of you, of course, but there is a way to remember these. I'll get to in the next slide. Are there any questions so far? I can't see the chat, so if you have a question, use the hand raise feature or just speak into your mic. Either one.